Good morning, champs! We solve this thermodynamics problem step by step, always combining the numerical calculation with the graphical representation in the PV diagram. We have nitrogen in a piston-cylinder system. The mass is 12 grams, the initial pressure is 1.2 bar, and the initial temperature is 40 degrees Celsius. First, we compute the amount of substance. The molar mass of nitrogen is 28 grams per mole. So, N equals 12 divided by 28, which is approximately 0.429 moles. We convert the temperature to Kelvin. 40 degrees Celsius corresponds to 313 Kelvin. Now, we determine the initial volume using the ideal gas law. Solving for volume gives V equals nRT divided by P. Substituting the values, we obtain approximately 9.3 liters. This is our first state. We now plot this point in the PV diagram at pressure 1.2 bar and volume 9.3 liters. Next, we go from state 1 to state 2. The process is isothermal and the volume is halved. That means V2 equals 4.65 liters. Because the temperature is constant, pressure and volume are inversely proportional. So, if the volume halves, the pressure doubles. This gives P2 equals 2.4 bar. Temperature remains unchanged at 313 Kelvin. We now plot state 2. In the diagram, we move along an isothermal curve up and to the left from state 1 to state 2. Now, we move from state 2 to state 3. This is an isochoric process, meaning the volume stays constant. So, V3 equals V2, which is 4.65 liters. The pressure increases to 3.6 bar. At constant volume, pressure is proportional to temperature. So, T3 equals T2 times P3 divided by P2. This gives approximately 470 Kelvin. We now plot state 3. Since the volume is constant, we move vertically upward in the PV diagram. Next, we go from state 3 to state 4. This is again an isothermal process, so the temperature remains constant at 470 Kelvin. The pressure decreases back to 1.2 bar. Using PV equals constant, we compute V4 as P3 divided by P4 times V3. That gives approximately 13.95 liters. We now plot state 4. In the diagram, we follow an isothermal curve down and to the right. Finally, we return from state 4 to state 1. This is an isobaric process, meaning the pressure stays constant at 1.2 bar. As the gas cools, the temperature decreases from 470 Kelvin back to 313 Kelvin, and the volume decreases from 13.95 liters back to 9.3 liters. Graphically, this is a horizontal line to the left, closing the cycle. We have now determined all 4 states and constructed the full PV diagram. The key idea is always the same. First, identify the process. Second, compute the new state. Third, place it in the diagram. If you follow this structure, even complex thermodynamic problems become manageable.